The Bermuda Triangle has devoured ships and planes for a century, fueling legends of aliens and dimensional portals. But what if the answer was always hidden in the ocean's mathematics? Researchers have managed to recreate what no one lived to tell: images of 30-meter monstrous waves that defy all logic. Today, we will reveal the scientific truth behind the disappearance of the USS Cyclops. If you are drawn to solved mysteries, like, subscribe, and get ready to face the true monster of the Atlantic. For decades, the Bermuda Triangle has been the canvas on which humanity has painted its most irrational fears. Aliens, submerged cities of Atlantis, interdimensional portals, and unknown energy fields have been the favorite explanations to fill the void left by ships and planes that vanished into thin air and water. However, in the oceanography and fluid dynamics laboratories of the University of Southampton, the mystery ceased to be a matter of faith to become a matter of data. Recently, a team of researchers delved not into the physical sea, but into a digital recreation of the Bermuda Abyss. What they were looking for were logical answers. What they found, or rather, what their systems generated and recovered from mathematical oblivion, were images that, according to traditional nautical science and the common sense of 20th century navigation, should not exist. They were not photographs taken by doomed sailors, but high-fidelity visualizations generated by state-of-the-art simulators. These images showed water phenomena of such magnitude and violence that they challenged the structural understanding of naval engineering. The study focused on the disappearance of the USS Cyclops in 1918, revealed the true monster of the Atlantic, not a biological beast, but a physical aberration known as rogue waves. This essay explores how these simulated images changed our understanding of the ocean and solved one of the most persistent enigmas of modern history. The fascination with rogue waves, or blue holes, has been a constant in maritime literature, but until recently, we lacked the scientific tool to convert them from anecdote to axiom. The simulation software's capacity to model the non-linear chaos of the sea surface with an unprecedented degree of detail was the key that allowed Southampton scientists to reinterpret the current and wind patterns that define the Bermuda Triangle. This region is a crucible of extreme conditions where the probability of a rogue wave emerging multiplies exponentially compared to other areas of the open ocean. The question was not whether these waves existed, but how often they manifested with enough force to annihilate a vessel as large as the Cyclops. To understand the impact of these new scientific images, we must first grasp the weight of the mystery. The Bermuda Triangle, an area of approximately 700,000 square kilometers bordered by Miami, Puerto Rico, and the Bermuda Islands, has been dubbed the Atlantic Graveyard. The legend was not born out of nothing. It was built upon real tragedies, and none was as baffling as that of the USS Cyclops. March 1918. The world was immersed in World War I, but the enemy that struck down the Cyclops did not bear a German flag. The vessel was a Proteus-class colossus, designed to transport coal and, on its final voyage, loaded with thousands of tons of manganese ore. With 165 meters in length and a crew of 306 people, it was one of the largest and most robust ships in the United States Navy. It was not a fragile sailboat or an experimental airplane. It was a floating mountain of steel. And yet, it disappeared. Only God and the sea know what happened to the great ship, President Woodrow Wilson declared at the time. There was no distress call, SOS, no wreckage, no bodies. The ship simply ceased to exist while crossing the Triangle region. For a century, this disappearance was the main fuel for conspiracy theories. How can something so large vanish without a trace? The absence of physical evidence allowed human imagination to fill the gaps. There was talk of methane bubbles that reduced the water's density, of abductions, and of magnetic anomalies. But the answer remained hidden, waiting for 21st century simulation technology to be able to dive where humans could not. This is where the University of Southampton researchers entered, armed not with sonars, but with algorithms. The scientific breakthrough detailed in the La Nation report and led by British oceanographers did not involve a physical expedition to the seabed, but the construction of a physically perfect virtual reality. The objective was simple but ambitious: to recreate the exact meteorological and oceanographic conditions that can occur in the Bermuda Triangle and subject a digital model of the USS Cyclops to that environment. Researchers began by designing a scale replica of the Cyclops. They not only copied its shape, but its weight distribution, its center of gravity, affected by the manganese cargo, and its structural resistance. Once they had the ship, they needed the sea. This is where the images that should not exist arose. In classical oceanography, waves are predicted using linear models. It is assumed that they have a predictable height and frequency based on wind strength and storm duration. According to these old models, a 30-meter-high wave in the open sea was a statistical impossibility, a myth of drunken sailors, something that happened once every 10,000 years. But when the Southampton scientists entered the triangle's climatic variables into the simulator, the screen returned something terrifying. The simulations began to generate waves that broke the scale. They were not tsunamis, which are caused by earthquakes and are barely noticeable on the high seas, but rogue waves, or giant waves. The image recovered from the simulator showed a vertical wall of water, dark and dense, rising not gradually, but suddenly in front of the Cyclops' digital bow. The height, 30 meters, 100 feet. To put it in perspective, imagine a 10-story building of water falling on a ship. These images visualized a phenomenon that science had long doubted, but which now, thanks to computing power, was revealed as the probable cause of the catastrophe. The existence of these waves in the simulation changed everything. It validated that the ocean did not behave in an orderly manner in that region. It behaved like a chaotic system capable of generating ephemeral monsters. The simulator, by combining the cross swells of the North Atlantic with the influence of the Gulf Stream, acted as a physical amplifier, demonstrating how a combination of ordinary events can result in an extraordinary event. This modeling process not only solved the disappearance of the Cyclops, but also provided the first rules for predicting when and where these killer waves are most likely to form. The international naval community has begun to integrate these chaotic models into their early warning systems. The mystery of the triangle, therefore, has transformed from a legend of terror to a serious warning for modern navigation, based on the implacable certainty of fluid physics. What exactly did the researchers see on their monitors? Rogue waves are beasts of physics. Unlike normal waves that form a predictable sequence, a rogue wave is an energy anomaly. It occurs when multiple smaller waves combine, or when ocean currents collide with the swell, compressing the energy into a single point. The essay must stop here to explain why the Bermuda Triangle is a factory for these waves, as scientists explain in the source article. The geographical location of the triangle is a perfect trap. According to the researchers, storms from 3 different directions converge in this area. Storms coming down from the north, storms coming up from the equator, and hurricanes sweeping in from the east. When these weather fronts collide, they create a chaotic sea state. Imagine 3 people jumping on a trampoline. If they jump without coordination, the canvas moves randomly. But if, by chance, all 3 land at the same time in strategic spots, they can catapult a 4th person to an impossible height. That is what happens in the triangle. Waves coming from the south collide with those from the north and the east. In moments of constructive interference, these energies do not cancel out, they add up. The forbidden image that the researchers recovered was the visualization of this exact moment of energy summation. A wave that absorbs its neighbors and rises like a wall. What makes these images so disturbing is their brevity. A rogue wave appears out of nowhere and disappears in minutes. There is no warning. Conventional radar might not detect it until it is too late. For the Cyclops captain, the sea could seem rough but manageable until, in a matter of seconds, the horizon darkened because the sea rose to cover the sky. With the simulation images in hand, the researchers were able to reconstruct the final moments of the USS Cyclops. This narrative, based on hard data, is more terrifying than any alien abduction. The digital model showed that the Cyclops' size was not its salvation, but its condemnation. Being such a long ship and loaded with heavy ore, it had a particular stability. The simulations revealed that if one of these 30-meter waves hit the ship at the wrong angle, the result would be catastrophic and instant. The key image of the study shows the braking scenario. If the wave lifts the bow and stern at the same time, or if it lifts only the center of the ship, the hull is suspended in the air without the support of the water. The steel, no matter how strong, cannot support the weight of thousands of tons of manganese without support. The simulation was brutal. The Cyclops did not sink slowly. It broke apart. The computer-generated image shows the hull breaking in two under the extreme pressure of the giant wave. A broken ship sinks in a matter of minutes, sometimes seconds. This explains the lack of SOS. The 1918 radio required time and power to transmit. If the ship broke and the engine rooms were instantly flooded, there was no time for the radio operator to touch the telegraph key. Even more unsettling is the stability simulation. If the wave struck broadside, a 30-meter wall of water would capsize the vessel as if it were a bathtub toy. The images recovered from the study demonstrate that, faced with such force, early 20th century human engineering was insignificant. Before the simulator unleashes the 30-meter wave on the USS Cyclops, let's pause in the eye of the storm. Bringing these scientific truths to the surface requires navigating complex seas of data. If you value this content that separates myth from reality, verify your subscription right now and give a strong like to the video. Your support is our radar for continuing to find fascinating stories. Ready to see the impact? Then, let's return to the digital laboratory. The phrase, "images that should not exist," has a double meaning in this context. First, it refers to historical disbelief. During the 20th century, many oceanographers denied the existence of 30-meter waves. It was thought that ocean physics limited wave height to about 12 or 15 meters at most in conventional storms. Sailors who reported walls of water were branded as exaggerators or liars. The first real proof that these simulations were correct did not come until 1995, with the famous Draupner wave in the North Sea, recorded by laser instruments on an oil platform. That wave confirmed that the ocean is capable of violating its own statistical rules. The images generated by the University of Southampton for the Bermuda Triangle case are the application of that new science to an ancient mystery. They should not exist because they break the linearity with which we like to see the world. We like to think that nature is predictable, that if we build a ship large enough, we will be safe. These images demonstrate the opposite, that singularities exist in the ocean, black swan events that escape all foresight. Furthermore, there is a psychological component. Seeing the simulation of the Cyclops' destruction is seeing a ghost image. It is seeing what no one survived to tell. Technology has allowed us to be post-mortem witnesses to a tragedy, recovering an ocean memory that was believed lost forever. The essay must address how this scientific finding displaces previous theories. The La Nación article is clear. The scientific explanation is sufficient. There is no need to invoke extraterrestrials. The giant wave theory is, in fact, more elegant and terrifying than fiction. Methane hydrate theories, suggesting that gas bubbles from the bottom reducing water density and causing ships to sink, are scientifically plausible in the laboratory. But there is no geological evidence of massive gas releases in the triangle with the frequency needed to explain all the disappearances. Magnetic anomalies, the compass pointing to true north instead of magnetic, are real in certain parts of the world, but they do not sink ships. They only confuse inexperienced navigators. And in 1918, the Cyclops crew was professional. The rogue wave explanation, supported by the Southampton simulations, covers all the gaps. It explains the speed. A massive blow sinks the ship before help can be called. It explains the lack of wreckage. A ship broken and crushed by tons of water goes to the bottom quickly. And in the depths of the triangle, some of the deepest in the Atlantic, wreckage is difficult to find. It explains the randomness. These waves are rare but inevitable given the area's climate. They do not attack all ships, only those unfortunate enough to be at the exact point of convergence. The images recovered by the researchers also speak to human arrogance. The Cyclops had a structural defect, its flat bottom and its cargo. Carrying manganese ore, a very dense material, the ship could have rolling problems. The simulations showed that if the ship tilted too much due to a giant wave, the cargo could shift or the ship simply could not recover verticality. The combination of a design intended for cargo capacity, not for survival in 30-meter waves, was fatal. It is fascinating and tragic to think that the engineers who designed the Cyclops did not have these images in mind. They designed the ship for the sea they knew, not for the sea that actually existed in the triangle's vortices. The images that today's researchers see on their screens are, in a way, the blueprints of the ignorance of a bygone era. This discovery has implications that go beyond solving a 1918 cold case. The images of the simulations force us to reevaluate current maritime safety. If the Bermuda Triangle is a natural machine for generating monstrous waves due to its geography and meteorology, then it remains dangerous today. Modern vessels are more resistant, yes. We have weather radars and satellites. But a rogue wave, by definition, is difficult to predict. The Southampton study images serve as a warning. No matter how much technology we have, the ocean has an energetic violence capacity that exceeds our industrial scale. The research also demystifies the area without removing its aura of danger. The Bermuda Triangle is not cursed by ancient gods. It is cursed by geography. It is a crossroads of storms. It is a place where the climate of the North and the South wage an eternal war, and ships are simply collateral damage in that atmospheric conflict. The final legacy of this study is a paradigm shift in naval engineering. It is no longer enough to design ships for a 100-year storm. Now, engineers must consider 1,000-year events as a real and recurrent possibility in zones like the Triangle. Stability criteria, especially for large cargo ships, must be revised to withstand the torsional and bending stress imposed by a rogue wave. The lesson of the Cyclops, revived by the computer, is that nature is not governed by comfortable statistics, but by the brute power of chaotic physics. This knowledge, although it deprives us of the stories of flying saucers, equips us with the truth to build a safer maritime future and, paradoxically, one more aware of how incredibly terrifying the ocean can be. Leave me your opinion in the comments. Do not forget to share this finding. Leave your like and subscribe for more declassified files. See you on the next tide.